send have meta information, like the particular unit that you're monitoring. A few others do not. So, a very high level picture of monitoring in the cloud. Some of the challenges, especially multi-tenancy and scaling, adding nodes in the cloud, sometimes dynamically, of course has an effect on monitoring. Here, for example, taking 60 items in a host, as opposed to 600 items, you can see that the number scales pretty much comparable to the number of hosts that you add. One idea is to apply the so-called Little's law. It's not Mark Little, by the way. Some of you may have heard of him or know him. Somebody else. Where, in this case, for example, the arrival rate multiplied by the response time. So you have, for example, 10 megabytes means data transfer rate of 2 megabytes per second times 5 seconds. What are the types of monitoring? So, on one hand, there's generally analyzing all sorts of logs, using Logstash, Redis, Elasticsearch, Kibana, or similar tools that can be related to application performance and consistency. But I've come across several large companies where they actually use these types of logs not only for analyzing if there's still enough memory left on a particular node, but they even went as far as to analyze the sales based on their online shop. So, for example, one of the largest pharmacy chains in Germany, DM, they also analyze, for example, how many soap bars or particular products are sold in a particular store, both online web stores, but also in the actual stores themselves. So they can, for example, find out if a particular product is more popular, or if there was a shortage of soap in a particular city, then they can allow to reroute that product from another shop where it may not be so popular. Here's an example of a Kibana dashboard, which also includes heat maps around the globe where you can see which part of the world users come from and where is the highest activity. For example, here you naturally have a lot of activity from the US, from Brazil. Yeah, you also know that they're very active in Java, open source, and IT in general, so it's not very surprising. India, well, obviously, a lot of things are outsourced there too. And I think those are the three main hotspots in this particular case. But yeah, there's an explanation. Monitoring performance, traditionally, without some unified tool or framework, you would have a large mix of all sorts of Bash, Python, Perl, and other scripting languages, often different for platform and operating system, and the proper analysis of that usually requires some context. So it may not be so easy to mix those and combine them. A very popular and also rather long-lasting tool is Performance Copilot. Who knows it or have heard of it? Actually quite surprising, because it comes with nearly every Linux distribution, not only Red Hat Linux, because Red Hat has taken over stewardship a couple of years ago and is now the main contributor. but started with a company called Silicon Graphics. They created high-performance graphic workstations for, I don't know, movies in the 90s, like Terminator 2 and similar ones, when the whole special effects just started. And to monitor the performance, where of course performance can be very critical in those environments, they created this more or less as a side product. So it's a little bit what you see nowadays with companies like Uber, some speakers from Uber here, or Netflix, SoundCloud, and all of those companies that are actually not IT vendors by themselves, but because they make those tools available. And even though Performance Copilot didn't start open source, but it became open source a couple of years later. And now it's available on GitHub and everybody can use it. And as you will also see, there are a couple of extensions, including some of the companies that I mentioned, like Netflix. So it's almost every Linux distribution, especially the professional ones, whether it's SUSE or Red Hat, you have Performance Copilot built in. It may not be active, you may not be using it, but if you use one of those professional Linux distributions, chances are very high that you may even have Performance Copilot on your system without knowing it. So, the basic concepts are agents and daemons. The collection daemon, PMCD, it runs pretty much like most of the other Linux daemons. It's just started up when the system does, via the Linux service mechanism. And then it gathers those metrics in irregular intervals. It can be every few seconds or even more often, or just every few minutes. That depends on how you configure it and how often you actually need to gather those metrics. These are some of the main components. The other ones that are built in, especially PMChart, is the rich GUI on Linux. But there are other extensions and third-party libraries that build on top that allow, for example, web-based analysis and charting. So, what's the metric made of? So every metric has a distinct, unique name. It has metadata. That's one of the things that Performance Copilot at least introduced very early. And not every single popular metric tool nowadays has such a rich level of metadata. I know, for example, the units are something that if you use drop wizard metrics or some of the derivatives in Spring Boot, those metric systems often do not provide a unit, so you have some value and you need to guess what it is. And if you propagate that value somewhere else, the information may be lost or misinterpreted. And then of course, there's an array of values, and every value is based on the semantics that are defined in the metadata. So every single value, if you know the unit will be, for example, byte, kilobyte, megabyte, or terabyte, then you know that the numeric values are coming and gathered in that unit. These are a couple of Tcp agents. So one example is the actual kernel and the core infrastructure of Linux, where things are gathered like available memory, process count, etc. Then there are some Linux-based specialized agents for Apache Nginx and others, and also agents for popular database servers. So they actually gather the internals of the database server just like they do for the operating system or other parts. And they all follow the same structure and same semantics, so it doesn't matter whether you want to know if the memory or the hard disk space on your system runs out, or if you're looking at your database, how many records it has, or if, for example, the file space becomes too large. inside the database, the table space, for example. All of this is gathered in a unified way, and therefore it can also be analyzed the same way, regardless of whether it's for the operating system, for applications, or the network, or the database. There are several clients. These are the most important internal ones. Then there are also remote clients, so you can have a remote analysis tool or analysis server that accesses several PCP servers and then accumulates the data and propagates it further, or allows you to look at all the different nodes from one centralized performance monitoring server. So here you see you have several PMCDs that are then accessed by clients. That can be on the same system, or it can be on a different server. Here, again, the data model, as mentioned before. Performance Copilot has literally a performance timeline, which is almost like the timeline that you may know on your Facebook or Twitter page. It allows both live monitoring in real time, or statistical prediction, or looking into the archives to see how the performance did or improved or degraded over a period of time. So here are examples for example, show me all of yesterday, show me last week, show me last month. Yeah, it's literally a bit like the timeline in a popular social network. In addition to its own built-in components, there are third-party applications and bindings that allow you to access Performance Copilot from your preferred environment and your preferred programming language. Because it's Java2Days, I will show most about a tool called Café. That tool actually makes use of the Java Units of Measurement standard JSR363, that I'm one of the spec leads. So they use, when they need to represent the unit as part of the metadata, they use the Java SE8 implementation of JSR363 to do so. So they also do it in a type-safe way. There are several components, for example, Performance Copilot metrics themselves, which are the more low-level metrics closer to the system. Via GMX, you can access almost everything that your Java application server or Java application exposes. And there are also others, custom extensions. For example, there are some for Spring, for JDBC, and many other systems, including some of the ones that I will also mention later, like Prometheus, for example. So, timing, in this particular case, it's basically based on what Java provides. So, all it needs here is a map for a particular thread, with the thread itself as the key, and the value that is retrieved. Here's a little example, I hope. Yeah, the screen is big enough. I hope, can you also at least recognize it in the back? This is just an example of some of the metrics. Here, for example, for a Tomcat or similar Java-based HTTP server, like Tomcat or Jetty or Glassfish. Café deals with requests, so you can also analyze via GMX and even all the way down to a particular thread context, there's a module called MDC, a buffet extension, that allows you to monitor and analyze the performance even down to a user ID or a thread ID. So that way, although it has no distinct tenant ID for multi-tenancy, but via the user ID, you could also add additional keywords and therefore have a metric performance analysis for not just one tenant, but in the cloud and the multi-tenant environment, you can also do this per tenant. With Google Go being more and more popular, of course, Docker is written in Go. Those of you who may have heard the news from Java1 that Oracle is now moving to a project called FN. That system is also not written in Java, but in Go. So you can access it from Java, but the server itself is actually written in Go. So that was one of the reasons why, similar to Parfait, there was also a project that is quite similar for the Go language, where you can do almost everything in a similar way. So, just going briefly over those, but those of you who have used Go already should definitely find this familiar. And you can see the unit, so Go may have some units of measurement support, but it definitely doesn't use the JSR363 as we do, but it also has a similar substitute here, so the unit here would be called one unit. That's where in JSR363, Parfait is using the standard component inside the JSR363 implementation. So there it would be called units.1 or abstract unit.1. Speed defined its own constants, but it fulfills the same purpose, and it also means, similar to Parfait or all the other PCP clients, it is aware of units, and it knows for each metric that, for example, 42 is in a 1 unit, or it may be in meter, or in kilometer, or in kilobytes, or something else. But you cannot mix them up because the unit is declared. Performance Copilot also added container support in recent versions. So for the sake of time, I'm also going briefly over those slides. Using namespaces, for example. Allowing to target individual containers. So here again you have the PM info, which is one of the command line tools of Performance Copilot, and it offers additional arguments, for example, -container to support containerized environments like Docker or similar platforms. Now let's come to another very popular tool, Drop Wizard Matrix. Who has heard of that or uses it? Does anybody use metrics in Spring Boot? No? Well, they are more or less, so a lot of them are at least interchangeable, and some parts of Drop Wizard Matrix are also used under the hood. So in some cases, not everything was completely invented from scratch by Spring and Pivotal. They also use some popular things like Kafka, Hystrix, or in this case, part of the Drop Wizard Matrix portfolio. So Matrix also has a lot of reporters for very different external systems, JMX of course, or SLF4J when you do log analysis, and advanced supporters for Graphite or Ganglion. Plus many third-party libraries for almost every popular system, including StatsD, which is by itself actually written in Node.js. So it's JavaScript-based and Node.js-based, but you can also talk to it both from Java or from Drop Wizard in particular. So Here's an example. And I mentioned that job wizard matrix does not have a distinct sense of unit. So what you have to do here is to actually use something. I don't have a laser pointer here, but in the third line you see that it uses something called the name, and the name has additional meta information for all sorts of tags. So it's literally like a tag or a hashtag in Twitter, and by that you can use the tag to say, okay, this is byte. But this is not a unit, it's just a tag, and in this case you can sort of abuse the tag to sort of get an idea what's in this metric registry and what's stored under that name. So that size is in byte. But it is not a distinct unit, it is just a string attribute that is used in the most reasonable way in this particular case. So here are some of the main elements of the matrix API. The gauge, a counter, which simply incrementing values, histogram, and a meter. Plus for time-sensitive measurements, there's also a timer that you can start and stop, and then take time differences. Matrix also has a graphite reporter, as mentioned. So you can propagate the values, for example, as in this case, to Grafana. Something that's very recent, but I guess even last year there were some talks and hands-on labs about Eclipse microprofile. How many of you have heard about that or participated? Yeah, so last year microprofile was actually still very new, and it contained nothing but the three basic JSRs that it's based on. This has improved quite a bit. So now we have health check and matrix. They are both somewhat comparable to the equivalents that you see in Drop Wizard or in Spring and others. And they are also interchangeable, especially in the matrix API, where I also helped that, for example, the unit is still a string in that case, so that each implementation can decide whether they want to use, for example, JSR363, or they want to use just plain enums. But the API leaves that open, but it calls a unit. And it's not just a label or a tag or some fancy additional string. It really calls it a unit. So it is a lot more in the spirit of Performance Copilot or other external tools, especially Prometheus. How many of you have heard of Prometheus or worked with it? Okay, quite a lot. Yeah, for the sake of time, it's just a very brief overview. And if we have 1 or 2 minutes, I may do the live demo of Performance Copilot, but because there are so many different tools, I cannot show every single one of them. But especially with Prometheus, almost all of the tools, so Parfait and Performance Copilot, they have bridges to talk to Prometheus, and the API of microprofile metrics was even, in some cases, tailor-made. And in the implementation, there are certain aspects that make it also very friendly to Prometheus. Here are some of the main components. And as you see, there are also exporters again to things like StatsD, Graphite, and other systems. So Prometheus can both poll various external systems, for example, Performance Copilot, but it also allows to export data down the big data or analysis chain to whatever external system you need. So, last but not least, something that's written in Node.js, but Prometheus again is also written in Go, by the way, so it's one of the reasons why Go is especially popular in this area, and why, for example, a performance copilot client written in Go makes it easier for people who, for example, then want to talk to Prometheus, because they only have to know one language. They may not even have to know Java if they have never known it before. And the same here. In case of Node.js, there's a tool called statsd, which was inspired by something with the same name created by Flickr. So I'm not sure if it still exists, but it was under Yahoo at some point. Maybe it still is. But it was also a good example of a company or a service that was actually for sharing images or videos like Netflix, and just because they have a very large server infrastructure, they ended up creating something like statsd, which they later made available open source, and this is sort of a Node.js port of it, or it's heavily inspired by it. By the way, in Eclipse microprofile metrics, the creators of Dropwizard metrics are also involved as committers or contributors, so you will also see a lot of familiar API elements. And if at some point the API becomes a standard, either JSR or widely accepted as an Eclipse project, then it is quite likely that Dropwizard may actually be one of the implementations. Okay. So, because there are some sessions over there with the awards, I should actually only take about half an hour, so I will do a brief live demo. Yeah, so this is the PCP charts rich GUI. And here you can see it's doing live monitoring of that particular VM and Ubuntu session. This is just the overview, so it's the most common metrics like CPU utilization, average load, network interface bytes, or real memory usage. There are plenty of more. I think there are at least 250 or 500 different metrics that you could show in this tool. So here you actually have to, if it works, yeah, so this is showing more or less the same data, but in this case it's showing the data via a web-based JavaScript interface called Vector, created by Netflix. So now you see the same real-time metrics in a different web interface that Netflix created and made available open source. So the PCP native tools are more for Linux if you have a rich UI. But if you're in a more web-based environment, and I also use this for some clients to measure and display the performance of their particular Jenkins slaves in a web interface that's consistent with the Jenkins dashboard itself, then something like Vector may actually be quite handy. And there are several other similar tools written in different languages, but Vector is definitely among the more popular ones. And from what I heard, I spoke to one of the guys at Netflix who was at Java2Days doing a book signing, and he said that, yeah, Netflix makes everything available open source. They currently don't intend to share it with, for example, Eclipse or Apache or the GCP, because they do it for themselves, but they do it open source, so everyone else can use it, including the likes of Spring and others. Okay. So that's it for the demo. I'm not sure, maybe one, maximum 2 questions, because then we're out of time. Any questions? Okay. Yeah, I already uploaded the slides from Apache Big Data last year, but since this includes new additions, especially the microprofile metrics, I will make the slides available on SlideShare, and yeah, these are the most important links for all the tools: Performance Copilot, Drop Wizard Metrics. Eclipse microprofile only has a start page, but if you go to the right repository, you will find health metrics and all the other features. Prometheus, and last but not least, Statsky. Okay. If there are no questions, then thank you all for coming, and I hope the overview was useful, and that you may find one or several of those tools in combination also useful for your performance monitoring needs.